everyone, welcome to another rendition of the Blank Wall video series. This is Mrs. Blankenship, and I'm here to talk about the liquid state. To start with, I'd like to talk about properties of gases versus liquids. And to start with, I'm going to use a syringe, and I have nothing in my syringe currently, and I'm going to go ahead and add some gas, drawing it in from the air. Then I'm going to put my finger over this and push it in. Notice that gases are compressible. We talked about that again in chapter 5. Then what I'm going to do is I'm going to show you by drawing up some liquid, and I have some food coloring in my liquid so you can see the color. And when I drew this up and now I try to compress it, no matter how hard I try, I just can't do it. Liquids have very low compressibility. They also have a high density in comparison to gases. And we can, of course, explain this talking about the particles and their distances between them. Gases are about 10 times as much or as far apart in comparison to liquids. Another important property of liquids is called surface tension, and you'll see it referred to as ST sometimes. Surface tension is the resistance to an increase in the substance's surface area. Polar molecules have high surface tension, and high surface tension indicates strong intermolecular forces. This is due to the fact that molecules are attracted to each other and don't want to spread apart. I encourage you to try to place a paper clip on the surface of water and see if you can get it to stay. Something that we know is that water has hydrogen bonding, strong intermolecular forces, and they're actually so strong that you can get a paper clip to rest on the surface of water. And there's a picture showing you the surface tension of water with a paper clip on top. The next concept we're going to talk about is capillary action, which is called the spontaneous rising of a liquid in a narrow tube or really on any surface against gravity. And I have a video to share with you to show this first. So as the video was showing, the cohesive forces are the forces between the liquid molecules, and then the adhesive forces are between a polar liquid and the sides of the container. Water's adhesive forces are greater than their adhesive forces, which is why we end up having a concave meniscus in a graduated cylinder. And this is true in both glass and plastic. We can see that in our graduated cylinders in our lab. The other thing that's important to know is that in a cylinder, the more narrow the cylinder is, the greater the surface area to that cylinder. And so the liquid will end up higher on the column for a more narrow cylinder and lower on the column for a wider graduated cylinder, or just cylinder in general, like a straw. Mercury is a really interesting case. This actually behaves in the opposite way. to water, since mercury is just an atom and is nonpolar. And so it does not want to be close to the plastic or the glass, and instead it has a higher attraction to the other mercuries, and therefore its meniscus ends up being convex. And here is a picture for you. On the left, you can see mercury with that convex meniscus, and then you can see the water on the right with the concave meniscus. The last concept that we need to talk about today is viscosity. Viscosity is also known as the resistance of flow of a liquid, which again will mean strong intermolecular forces. Now, I'd like you to think about the answers to these questions that we can discuss in class, why viscosity increases with those increased in intermolecular forces, and then also with molecular size. So please take a few moments to think about that and be ready to discuss in class. So just to summarize what we've talked about so far for liquids and also in comparison to gases and solids. Models for liquids are really tough to draw and think about. It's a little bit easier to compare them to gases and solids. And so gases have very weak intermolecular forces and have lots of motion, whereas solids have very strong intermolecular forces and next to no motion. We talk about vibrations of solids, of the bonds, rather than the actual solids being able to, the molecules being able to move. Liquids, however, have both strong intermolecular forces and quite a bit of motion, and so that makes them more difficult to model. All right, that concludes section 10.2 on liquids. Can't wait to see you guys in class and talk more about this. I hope you have a good evening. See you tomorrow.